So I'm trying to load the part that you sent us. Now, VisualCAD CAM can also bring in files from a variety of different file formats or CAD systems. You could be working with IGES, STEP, STL, Parasolids, native Rhino files, DXF, DWG files. So there's a whole bunch of file formats you can bring into VisualCAD CAM, and as you go into your file open dialog, you'll see all of these file formats are in here. So VisualCAM can read from any of these formats. Now, since you already had the file saved as a VCP and emailed to us, I just loaded the part directly into VisualCAD CAM.
Right. I created that out from a step. It's kind of a multi-step process for me because I have to turn it. I have to save my native files as a step, and then I can turn the step into a VCP.
That is correct. So you can bring it in, open a step file, and then just save it out as a VCP. And you can, when you add CAM information, the machining operations, they're all saved in the same file format as, the VCP format. So it gets added to it. So once you have the file loaded in here, the first step you would want to do is go through the machining browser to, define the machining process in here. So there's 3 different groups under the Program tab. You have the machine setup, you have stock, and then machining operations. Now, under the machine setup group, you define the machining process. For 2 and 3 axis operations, you would leave it as 3 axis. If you have a need for programming the part from multiple sides and you have a rotary table, that's where you could use 4 axis, or if you have a 5 axis machine tool, you would be selecting 5 axis. So we have different configurations of our product, and depending on the configurations, you opt for, you'll have those features available to you.
Right.
Now, once you have the machine type defined, you notice that the machine type is defined as 3 axis under machining job. The next step is to select your post processor. This would be the machine tool that you're going to be outputting the G code for. Now, the post processors in here are listed either by the name of the machine controller or by the actual machine tool name. Would you happen to know what is the post processor you're going to be needing, or the machine tool you're going to be working with?
Yeah, we have on order a Haas VF4.
Okay, so if you look at the list of posts in here, there's one for Haas, and you can pick this, and this will work for pretty much all of the Haas machine tools. And if you need any modifications or customizations to this, we could always help you do that. So there's a post generator that's built into the product, and this is where we go in to tweak the posts around as well.
Okay. Now, do I have to define anything about the machine, or does the?
Nope. You just have to leave it as 3 axis and then select your post processor. That should all. Okay. That should be it.
Okay. Cool.
In the next step, we want to define our stock material, which we call, which is your workpiece, the size of the workpiece blank. Now, automatically, the system will analyze the extent of the part and determine the minimum size you need for it. So it tells you the minimum length, width, and the height. Now, if you need to leave, some extra material around the sides, you can use, change the length in here, or you can even define it as a part box stock by giving it an offset distance in X, Y, and Z. Now, would you typically be starting with the stock that's exactly the same size as the finished part?
Yeah, we order it. It's jig plate, so we order cut.
All right. So I'm just going to go ahead and leave it as 25.25 and then pick OK to accept it.
Okay.
All right? So in the next step, you would want to go ahead and establish the alignment of the stock to the part. So you would do align and pick align stock. So you want to, if the stock was larger, then you can choose to position it in the center, in X and Y, or to one of these corners, or if it has more thickness than the part itself, you can choose a Z alignment as well. And in this particular step, since the part and the stock heights are the same, and the extents in the X and Y are the same, we can skip to the step of aligning the part and the stock. Now, you also want to make sure that the part is oriented correctly, which means that there's enough room or enough travel available on the X-axis, because the way you currently have the part set up here is the length of the piece is oriented along the X-axis, which means you need to have at least 25 inches of travel available to be able to mill this part. Now, this is typically the case in most CNC mills. You have more travel on the X when you compare it to Y. If you're working with a router, you might have more travel on the Y as compared to X, because most routers have, 4x8 work envelope where 8 is basically on the Y-axis.
Okay.
All right, so we got this part oriented. We have the stock defined. The next step is to establish your origin. So when you place this workpiece on your CNC table, you want to zero out to one of these corners. This could be also called your work coordinate offset, or G54. So you can pick one of the corners in here, or if you want to leave it where it is, you can leave it you don't have to make any changes in here.
We always work off the back left corner.
Okay, over here?
No, the one behind it.
Okay, the northwest?
Yes.
Okay, so the way you could do this here in Visual Mill is going to align and set world coordinates. You pick set to stock, higher Z, if you want to put the Z0 at the top of the stock material, and then pick south northwest. So that basically would establish your XYZ origin. So it actually moves the part and the stock right to the world coordinate system origin. When you pick OK, it transforms it. So now your XYZ origin is established right in here.
Okay.
So your Z0 is being set to the top as you notice it.
Okay. I've pretty much I've played around and gotten to this point. So everything you're doing so far to me is, pretty familiar.
All right, great.
Mistake in that drawing. It's okay.
So we'll go through the process of programming these pockets in here. So you have some open slots, you have some open pockets in here, as you see it right there, right?
Right.
So we have these features that you like, and also you have a bunch of holes in here, like counterbores on the part that you like to program, right?
Right. And just so you know, it makes a difference. We use a special drill to make those with a counterbore on it. So they get drilled and counterbored at the same time.
Okay, so basically you have a special tool where in just one pass you can accomplish both, is that right?
That's correct.
All right, I could show you how to program it in here. So, we have a feature called Feature Detection and Machining in our 2017 version, and this is offered right from our standard configuration. So we can use those for identifying the features from the part. For example, I can select Create Machining Features, and I can go pick this face and the part right here, and this will automatically identify features on the part right in here. As I select them, I can right-click on it, and this will automatically go through the process of analyzing the part, and also it will detect the features on the part. As you notice here, it identified a planar face. It identified these, hole features in here. As you notice, it identified all of these holes are like a pattern of holes, and there's multiple hole features we were able to identify. We have hole feature number 2. There's set up 2 holes, and we have this hole feature in here, which basically identifies these row of holes for each of these, features on the part right there.
Okay.
As you notice, it also identified this hole right there and the one over here. Right. So we can take advantage of these feature detection techniques to program these features, and also you can see that it identified this as a slot in here, as a prismatic slot right there.
Right.
And we also have, we can identify this slot in here by picking this face, or we could use different techniques. Now let's go ahead and program these holes in here. So you have about 24 of the holes of the same type. So you can right-click on this and then choose the type of operation you would like to program in here. So you want to do a drill, a spot drill, drill and a tap, you could do that, or you could basically just do one operation. You can right-click and choose drill, and this automatically previews the cross-section information of the hole.
Okay.
It shows the diameters, the smallest diameter and the largest diameter, as you can see, 0.27 and 0.164, and then the total depth is about ½ an inch, right?
Right.
So if you want to program all of this in just one step, you make a selection for the tool, and you said you have a special drill tool for it, right?
Yep. Yep.
So you can specify your tool types in here. I can go to drill, and you can define it, or you could even define it as a, if you want to define it as a center drill, you can do that as well. Or you can just go define it as a standard drill in here that you have. You can specify a diameter for the drill bit, so you can go ahead and specify the tool diameter in here. I could say 0.25 quarter-inch diameter. Specify the tip angle in here, and if it has a 118 or 120 tip. CAN cycles like G81 for a standard drill, or a G83 for a PEC drill or a deep drill cycle.
Okay.
All right. The next step is we wanted to go ahead and program the other hole features that you have in here. So right-click on it, and then you can use drill, and it automatically also establishes the feature for the counterbore in here. Or if you want to add this, if this is the exact same one as these in here, you can actually go back in here, edit this operation. you can go ahead and select the whole feature. You can add that to the list and generate both of them in one operation.
Okay.
So all of these holes are generated. Now I would go back and program these holes, right-click on it and choose.
These get drilled and tapped.
Right. So you need to drill and tap them, but before you drill and tap them, you may want to pocket these areas out, right?
Yes.
Okay. So we could use in a couple of different ways to program the pocket. One of the ways I could do is extract what is called a sketch from this part in here. I can use this tool called flat area, and I can just pick this face, and I can also repeat the same step to pick this face right in here, and this actually creates a boundary in here. As you can see, it creates this curve boundary around the part as you notice it, right? It creates those curves, and I can also place them on a different layer, so that way you can actually see those curves that were extracted in here. Now on one of these curves, since you had a hole on it, it actually shows that also. So we won't need to have that. Actually, you could have it suppressed, or what we can do, since these are identical features in here, I can select this and do a copy in here. So do a transform, I can do a move command, and I can choose pick from point. I can move from an end point right in here because those features are identical. Pick to point, I can move it to this and say one extra copy right there, and that basically creates a copy of that. And now I can go back and delete the one that had the holes on it, so I can basically exclude them right here. I could do the same thing for here. If I wanted to explode it, I can explode and then basically, fit a arc around it. So we have some very neat, curve tools in here, so we can use them for our toolpath as well. So I can select this and do an explode on it. There's commands in here in the curve modeling. I can do an explode, where I can basically break them into lines and arcs, and now I can go back and recreate a new arc in here, so to basically connect these two together, right? Or I can basically select these and just create an arc. I can go to the arc commands in here. You can see there's different ways how we can create an arc. You can use the three-point arc, or you can do start and on, or I can leave one of these arc segments in here and create an arc and use the snap tools in here to snap to the center, and I can get the center point. As you can see, the center of the arc is right there, and then I can use the end point snaps in here to basically snap to the end of the line, and I can basically recreate those arcs right there for us, right? So I can recreate those arcs and basically use them as my control geometry for programming it, and I can also use the move command to basically drop it down here in the Z. So now I have this created in here, and I would like to leave the end of this open since I want the cutter to approach from the side, from the exterior, or I can offset this out and then program it as a pocket operation if you want to do it that way. So in this particular step, I'm just going to go ahead and merge them together, join, merge. So basically they're joined. Now I'm going to take this curve and do a copy in here, transform, move, pick from point, go from the end point right in here to the end point right over here, and I'm going to make one extra copy, so that way we can get rid of the other one right there, right? So we now have the geometry that we need for the pocket, creating the pocket toolpath. So I'm going to use two-axis machining, and I could use facing operation, and facing can be used for programming the open pockets. So all I'm going to do is pick these curves in here and select them, right-click to accept it, and what size cutter would you like to use for programming these?
We use a 7/8, I believe.
Okay, is the width the same as the slot width, the tool diameter?
Okay,
that is 0.59.
I think the slot is slightly larger than that.
Okay, so we could use a profile operation in here then. That would be the most efficient way to cut it, and you don't need to do a facing. You could just do two-axis profiling, and you could choose you said a 7/8 cutter?
I think it's 7/8. Oh, wait.
Okay.
Actually, I think it may be, hang on a second.
7/8 would be a little too large for the slot.
Hang on a second. Let me do some math here real quick. I'm sorry. 455, 1044. I'm sorry, those slots are 590. So
5/9. Yep.
Okay, so it must be a half-inch end mill, because I know half or 7/16. Fairly Bill.
All right, I'm going to go with a 1/2 inch here. And then we'll pick the climb cutting. We could determine the side to cut based on the 3D model, so it knows which side to place the cut levels. The features, what you picked is at the bottom of the floor of the pocket, and then you can measure the depth in here by just picking 2 points, a top edge and then a bottom edge right there. It's only 70,000. You can go in like 1 or 2 passes. If you want to just do 1 pass, you can just leave it the way it is. And you can also specify a lead in and lead out in here, so the cutter will extend past the geometry in here, and you can specify these and then do a generate. So that'll get you your profile cut and just go around it. So you can program this, could be your first operation if you want to run a profile pass on it. Now there's pretty nice features in here in the simulation. We can set a color for each of the operations in here. So you can right click and go to properties, and then you can pick a different color for the simulation in here. And now when you run a verification, you can see that the cut material color for each of the features that you're programming could be set differently.
Okay.
So there's,
if I'm doing 2 passes, I can just tell it what I want the roughing pass to be. And
absolutely. We could break it up into 2 levels. We can go to cut levels. We could say we want to do 2 passes, 35,000 each, and then we could generate the tool path in here. So that'll give us 2 levels.
Now, what if you wanted to change tools and do like with a rougher and then a finishing mill?
Sure, we can do that. So what we can do here is in the profiling, we can specify to leave some side stock or wall stock in here, like 5 thou.
Okay.
So stay off the edge by 5 thousandths. So it's basically going to stay off the side walls by 5 thousandths. So it's not going to go and clear it up. Now I can go back in here and make a copy of this operation again.
Right.
And modify this and pick a smaller tool, like go from a 1/2 inch down to a 1/4 or 3/8, and then basically just specify the stock to leave as 0, and you'd probably want to just go in 1 pass to clear that out, and that'll get you 1 pass. And you can basically go back in here and go to properties and set a different color for the simulation in here. So I'm going to pick this green right there. Okay. And when I run a simulation, you can see that it's cleaning up the material that was being left from the previous step.
Cool.
Now all of this information that you're programming in here, you can save it out to a knowledge base, which allows you to reuse the same operations on other parts which you have similar features. You can reutilize them. You might have plates that could be slightly different sizes or for different components in here, so you don't have to go through the process of reprogramming, reestablishing all your toolpaths. So you can basically take advantage of saving these into a knowledge base.
Oh,
now
cool.
In the next step, you would want to go ahead and cut these slots in here, right? This particular one right here. So if I do measure the distance in here, I could do analyze distance. So I want to figure out what size cutter I would need for it. So this is a little over 1/2 inch.
Yep.
So we could do 1 pass on each side to clear it out.
Yep.
So one of the ways I could do is pick a edge right here. Since on this side we don't have a straight edge, I could create a line geometry, like a curved geometry in here for the other side. So I'm going to use the line command, and I can create the line either at the top edge or I could create it at the bottom edge. So I'm going to just create at the bottom edge right in here. Draw a line for the 2 sides.
Okay.
Now, since we already programmed the profiling operation in here, so I'm going to make a copy of this. Right-click copy, right-click and paste. And now I'm going to modify the profile operation I created in here and select these 2 edges. I'm going to pick this edge right here. And in this particular case, I'm going to pick this line right there. Yeah. And now I'll specify it to cut. And in this particular case, the depth is going to be different in here. So I'm going to pick the depth to be from the 3D model. So I'm going to pick the depth. And it's only 5 thousandths. We could probably go in 1 pass. And if you don't want to leave any side stock, you put that to 0, generate. So that'll get you a profile pass in here. And that would basically go, on the sides right there. So you can use 5 thousandths. You can specify the parameters in here, and you can generate the toolpath. Now, if you wanted to change the direction of the cutter, in this particular case, you can see that it's looking at the direction of the curve. I'm going to reverse the direction of the curve. I can flip the curve direction right in here. And now I can go back to this operation in here, and I can choose which side to place the cutter, use cut right or cut left, and that'll choose which side to place the cutter. So right now you can see the cutter is going on the outside. You want to flip it, you can change it to the left side. It'll go on the inside right there. So it's doing one pass on each side of the curve to clear it out.
Okay.
And then you got the profile finishing pass with the smaller cutter right there. So that cleans out the two profiles. And then you got your drilling operation programmed.
Right.
You can always do a pause and click simulate to end. And the next thing you want to do is tap these holes in here, right? Drill and tap.
The holes that are inside of the slots that we cut.
Yeah, so you basically want to do
it. And those are, we haven't.
We have a dimension here. It's a 097, 0997. So we can go ahead and program.
It's a number 4 tap.
Okay. As far as, do you want to do a drill before you tap, right?
Yes. Oh, yeah, we'll drill
okay.
first.
So we'll add a tool in here. We'll do a drill bit, and it would be 0.097. And we're going to call it 097. You can specify the tool length, all the tool properties, save this out as a new tool in here. And the depth, everything is automatically established from the geometry. You can see the depth is 0.43, and if you want to just do like a peck drill, you can do a peck drill as opposed to just do a standard drill. And then you can also sort them based on a minimum distance generate. So that got your drilling operation. Now I can go back and edit this and also add the other feature in here that you have. So you can have both of those being drilled at the same time.
Okay.
And there's our drilling operation. So you can see the drill, peck drilling routine.
Right.
You can always do a pause, simulate to end. And once you're through with the drilling process, you'd want to go back and do a tap on it. So right-click and then select tap, and you basically have the whole feature. You can add the other whole feature as well in here. Add it to the list. All features 3 and 5 are selected. Add a tool in here. And do you happen to know the tool?
It's a 440 spiral tap.
Okay, so 40 is threads per inch. That would be 25, right? And what would be the diameter of the cutter, the tap? You say it's a 440 tap?
Yeah.
Okay. I'm going to bring up the drill chart in here. I have a drill chart with me here. I can bring that up here for the tap. And I'll look for a 440 in here. So looks like it's 0.098.
Okay.
Which sounds right. And I'm saving this up as a new tool right there. And then we can set the feeds and speeds in here. If you put in like 500 RPM, the cut feed rate would be automatically computed. It would be 500 times the pitch. So it'll compute the feed rate for you. And then you already have all of the information set up in here, your depth and all the parameters. All you got to do is set the sorting, and there's your tap operation. So you got your drill and then the tap also programmed. It just shows like a drilling operation, the tapping.
Right.
And select pause and simulate to end. And there's your simulation. So once you have all of these operations programmed, right-click and information will give you your estimated machining time on it. And then you want to post-process, right-click and post. That'll write out your G-code. And you can see it has all the information. You can also put the tool list at the start. There's your tools. Each of the tools are listed. You got your G54, calls out your first tool right in here, calls out your height offsets, and your toolpath right there. So it goes through each and every operation. And then you have your drill, and then finally you have your tap. The feeder is computed as 12.5. So 500 times 25,000 is 12.5.
Okay, I got
The
it.
program is ready to be sent out to the machine, so you can just transfer it out if you're using a USB or if it's an Ethernet or however you're trying to communicate to the machine.
Okay.
And saving this file automatically saves all of the machining operation to the VCP file that you created. Now, you can also take all of these operations in here and put them into a knowledge base, save it to a knowledge base.
Okay. Yeah, we make a whole bunch of different links of this same part.
Mm-hmm. You just bring in the knowledge base, you just pick the new features from it, and then generate the toolpaths.
Okay.
Now, if you wanted to do a facing operation at the top, you can pick this planar face, right-click, and choose facing. You could use a face mill and just like go linear passes back and forth. You can run it one pass, so you can basically face it down to a certain thickness if you need to.
Right.
And that could be the very first operation on the tree. And since I haven't specified any depth in here, I can see that it's just basically surfacing on top of the material. There be any questions so far, Phil?
Oh, just kind of amazed.
You see how easy it is to work with. You know, you have all the workflow established and reuse the same operations on other files. Now I see you got some holes on the side. How do you plan to machine these holes?
We do those manually. There's just a few of them. And it's almost, by the time you do the setup and the CNC, and it's just faster to do it manually.
Okay, the reason I asked you was in our standard configuration, you can program the toolpath from one of the sites. If you wanted to program from additional sites, you got to rotate the part, save it as like side 1, side 2, etc. Or if you're looking at our Pro configuration, we have a add-on feature that's a very nice feature called Setup, where you can actually rotate the coordinate system for machining. So for example, if I want to drill the holes that are over here, I could just rotate my coordinate system in there by, let's say, minus 90 degrees, and now my z-axis is normal to that particular side, and now I can go ahead and program the drilling operation from this particular face. So I can identify the features in here for this orientation. I could select this face right there, and it'll identify those, detect those features, and I can program those holes from those features. Okay,
and that's going to come into play because some of the other parts of this device, you know, have multiple, you know, there are multiple setups.
Okay.
To make them, you know, because they do get rotated, and because we're machining different sides.
Okay. Now, does your VF04 also has a rotary table to be able to do 4-axis machining?
No.
Okay. Yeah, the Pro configuration offers you more additional features like multiple setups, advanced 3D operations, milling operations, and also you can program 4-axis as well, or like 3+2 machining or programming from multiple different setups.
Yeah, I think I'm trying to remember which one I was looking at. I was looking at there's Expert and there's Pro, I think.
Yeah, we have Standard, Expert, Pro, and Premium. Standard is the one that offers you 2- and 3-axis operations. So what we went through earlier was done with the standard configuration for the top orientation here. So these features, the Expert adds the 4-axis capabilities. The Pro offers advanced 3-axis. It also includes machining from multiple different setups or orientations, and it includes, 4-axis as well.
How much is the Pro?
Yeah, I can get you all the information about the pricing for different configurations. Now, before I provide the information to you, would you happen to have any additional questions on the demo I could further assist you with?
Like I said, had gotten to a certain point. I mean, with, where I got to the point of like, I had the drawing in there. I went through the machine setup portions and stuff like that. Where I hadn't gotten to was how to I hadn't figured out how to select the features and all that stuff.
Okay.
So that's kind of, I think I just have to work at it and play around with it. I wrote some notes while you're doing it. And I've been going through your help. What I've been doing, I have 2 monitors, so I put your help up on one, and then I put the the screen up on the other. I've been kind of working my way through it.
Okay.
So I think I got a understanding. Like I know on the on the demo version it doesn't let you do a lot of things, so it's kind of
Yeah, the only limitation on the demo is you can't post the G code out, or you can't save these operations out to your file. But you can work through all of the programming steps that we did here. You can do that in the demo as well.
okay. Now, I was looking at the standard version.
Okay.
So in standard, like if I have a part where I have, say, on the first machining operation, I have, I take off some material, and I make a couple of cuts, and I make a couple of holes and a couple of counterbores. Then I take that part and I rotate it 90 degrees, and I put another hole in it. And that, can I do that with standard, or?
You would have to have two separate files in here. So the first file would be basically programming like just what we did here,
Okay.
right?
Right.
And in the second one, you would basically, in this case, you do a save, and then you rotate the part and save it as a copy. So I could select the part and do a transform, rotate it, and I can say I want to rotate on the X by 90 degrees. So I could do some of the holes on the side. So I rotate the part right in here, and you would basically save this as a new file, and then you can program these holes in here. So I could go into hole machining, drilling, and I can select holes on this face right there. I could pick holes in a flat area, grab a tool for that. I can say drill 1/8 inch, and specify a depth for it in here. I could use maybe a 1/4 inch deep, and then generate. And that could be a separate program by itself.
Okay. Yeah, because
program from all the different sides within the same file, you'd have to basically create copies of the file, so that way you have, you can still program it. So this would be output as a separate file.
Okay. We don't do it, and truthfully, when we do that, I mean, if we're making 100 parts, we do operation 1 for all 100 parts, then mechanically change the setup for the second operation. So the fact that it would be 2 different programs probably wouldn't be a big deal.
Yes, that is correct.
I just have to make some adjustments in how I bring it into the CAM program.
Yeah, you can just reorient it in here and then save it as, for example, a part 1, side 1, part 1, side 2, part 1, side 3 for programming each additional sides.
Okay. Yeah, that's easy enough. I only have a few. I only have a few that have both sides.